We are ready to go. Okay, I got you recording.
Okay.
Go right ahead, Brad.
Okay. Good afternoon. My name is Brad Beall, and today I will be presenting on my capstone project, the 2012 Pine Creek, Montana wildfire, a comparative analysis using the normalized burn ratio and the normalized difference vegetation index. Pine Creek is a small unincorporated municipality located on the Yellowstone River in an area of southwest Montana called Paradise Valley. On August 29th, 2012, a Pine Creek resident was operating a backhoe near his home. His metal bucket struck a rock, sending sparks into a nearby patch of dry grass and trees, and in spite of the panicked efforts that followed, the fire quickly got out of control. Over 100 firefighters fought the blaze, and it burned for more than a month before it was contained. It wasn't a large fire by modern standards, and fortunately, nobody was hurt, although 5 homes were destroyed and 8,500 acres of combined Absaroka-Beartooth National Forest and agricultural ground burned before the fire was put out. The fire ranged in elevation from 4,800 feet in Pine Creek to over 9,500 feet in the Absarokas. The west side of my study area here is primarily agricultural land where native trees and vegetation were cleared away many decades ago. The east side is wilderness in the truest sense of the term. It has challenging backcountry terrain with some of the peaks exceeding 10,000 feet. Prior to 2012, Paradise Valley had seen no wildfires in historic times. How did we get here with our forests? Why are wildfires so common and so lethal nowadays? Well, by the late 1800s, a series of fires convinced Congress that America's forest resources needed protection. In 1905, Congress established the U.S. Forest Service and charged it with protecting our forests through a strict no-fire policy. No fire, regardless of cause, would be allowed to burn in the new national forest system. Now, this betrayed a deep misunderstanding of the salutary role that fire plays in keeping our forests healthy and clear of dead plant material. The no-fire policy was so effective, though, that by the late 1960s, an explosive amount of dead trees, leaves, needles, and grasses lay on the forest floors. And to restore a healthy balance, the Forest Service was forced to trade the no-fire policy for one of let burn. Once a fire had started, it would then be allowed to burn as long as there was fuel to sustain it. The risks were significant to human lives, of course, and to infrastructure. Just as important, high-intensity, long-duration wildfires can alter the physical and chemical composition of soil. Minerals and nutrients are lost through extended heating. Soil becomes impervious to water, and if severely burned areas are not remedied within 3 years of a severe burn, the changes can become permanent and forest ecosystems can be lost forever. The goals of my project were 3. First, to determine the overall burn severity of the 2012 Pine Creek fire. Second, to determine whether and to what extent vegetation is returning to the study area. And third, evaluate the effectiveness of NBR and NDVI indices by ground truthing 4 test sites in the study area. The unique reflectance characteristics of vegetation and soil can give us valuable information about burn severity, plant health, and plant density. NBR uses near-infrared and short-wave infrared wavelengths in its formula. Healthy vegetation reflects near-infrared well, but short-wave relatively less so. And healthy vegetation reflects, the reverse is true for burned areas. When combined mathematically, NBR yields a range of values from -1 to +1, where negative values correspond to burned areas. NDVI is analogous, but instead of using shortwave infrared, NDVI uses visible red light. Chlorophyll in healthy, dense vegetation absorbs visible red light, while unhealthy, sparse vegetation tends to reflect it. And near-infrared is reflected by all vegetation types. When reflectance values are combined mathematically, the results range from -1 to +1, where 0.2 is considered the lowest possible value for living vegetation. In order to calculate post-wildfire burn severity, post-fire NBR reflectance values are subtracted or differenced from pre-fire values. The results are classified on a scale, and when applied to a study area, they show regions of relative burn severity. And this would be the scale that is commonly used when assessing burn severities after a wildfire. NDVI has no corresponding difference function. So the original results are classified on this 4-class scale. It's a common scale to show the relative plant health and growth density. I ran into some challenges using NDVI in my study, and I'll explain those in a minute. My methodology was the same for both indices. First step was to download my data sets from U.S. Geological Survey's Earth Explorer data portal. Challenges I encountered with that: 1, controlling for seasonal growth; 2, dealing with cloud cover and haze. Those were ever-present issues. And 3, Landsat 7. That was the first satellite that I used data from, and it has some hardware issues that translated to some difficulty in using those data sets. I'll have an example of that here a little bit later on, but suffice it to say, I had to rerun my NBR studies with Landsat 8 and 9 data sets in order to get over the issues that I found with Landsat 7. Step 2, because of the way that collection 2 level 1 data sets are stored, they have to be rescaled prior to use. So I wrote a small program in ArcGIS Pro's model builder in order to do that. Step 3, I calculated my NBR and NDVI values through 2 additional programs that I wrote in model builder. Step 4, I digitized the wildfire boundary using an early data set from the Burned Area Emergency Response Team. This organization provides support to firefighters. They take the earliest data that you can get from a fire, and they produce a variety of data sets. Included amongst them are some burn boundaries. I use that as kind of my base outline, but I cross-checked myself using my NBR and NDVI calculations. Step 5, I extracted NBR and NDVI values from the study area using my digitized burden boundary. And then step 6 was classifying results. For NBR, I produced my DNBR rasters for all years of the study, and then I classified them using the common scale. And then for NDVI, I went straight into classifying my results. Now, a word about NDVI. This was my first time working with NDVI. I added it as a supplementary investigative tool when I started seeing strange results in my first round of NBR results. What I discovered is that NDVI is not a simple off-the-shelf tool to use. When I ran my first NDVI calculations for 2011, 97% of my study area classified in this 0 to 0.33 unhealthy range. So my first pre-fire year was filled with unhealthy plants, and I knew that that wasn't correct. The common scale, this one right here, has to be customized for both the plant type and characteristics of the study area. And in order to do this successfully, you have to have baseline values for healthy vegetation and for growth densities. I had neither of those for alpine forests in Montana, and there was no way to go back and produce any without extensive ground truthing, which I was unable to do. I couldn't reproduce 2011 since that was gone. And because I was working on this project in the wintertime, there was no way to go out to Pine Creek and create my own control plot with NDVI values. It was wintertime and it wouldn't have worked. So alpine forests are a different beast from single crop fields, which is where NDVI is very commonly used. Alpine forests have a mix of vegetation: conifers, deciduous trees, grasses, shrubs, and flowers. Single crop fields don't have that kind of variety. Wild plants, similarly, they don't grow in rows, which makes gauging plant density a bit of a challenge. Because of the limited range of values for healthy alpine vegetation, all of my earliest maps, NDVI maps, were 2 and 3 color blobs showing a variety of sick plants, and that wasn't going to work. So my solution, as inelegant as it was to subdivide these 3 classes here, the unhealthy, the moderately healthy, and the very healthy, into 3 separate subdivisions. So unhealthy level, so I'm going to move that over. Unhealthy level 3 is the least healthy short of dead plant material. Better than that is unhealthy level 2, and then unhealthy level 1. Moderately healthy 3, this I found was probably the healthiest classification that I ever found in any post-fire study that I did. So it's a little bit confusing, and I apologize for that. But even so, adding these subdivisions allowed me to see more NDVI variation in my study area. If I'd had baseline values for these forests in Montana, it would have been a lot easier to develop a workable classification scheme. And that's why I will file that under the what I would do differently next time heading. I'm going to walk you through 3 results from 3 years of my study, my pre-fire year of 2011, the first post-fire year of 2013, and then the last year of the study, 2022. Each slide is going to show DNVR results, NDVI results, and then the charts showing value ranges for each of these 2 indexes. So in 2011, most of the study area classifies as unburned, and only 7% of the study area has an NVR value of 0 or below. On the NDVI side of things, again, bear in mind that in 2011, this was a healthy alpine forest, and the darker orange colors indicate healthier vegetation. The mean NDVI value was 0.2, which was the lowest classification on the common scale for living vegetation. So from a reflectance standpoint, this is what a healthy forest looks like in Southwest Montana. 2013, the first post-fire year. After the fire, you can see a mix of burn classifications. The predominant burn class is low, but there are significant areas of moderate low severity. And there were 9 pixels I found, I think 6 of them here, 2 here, and 1 up here that indicated moderate high burn severity. It was limited, but it did get that hot. The NBR value in 2013 dropped to near 0 from 0.2, and over half of the study area had a value of 0 or below. NDVI, you can see that the east side of the study area has shifted into the unhealthy 3 category, and the mean has dropped from 0.2 to 0.14. So that's below the lowest value for living vegetation. These green areas on the west side, they may be a consequence of irrigation. Ranchers with water rights out there irrigate all summer long, and most of the west side has an agricultural use of one kind or another. And I say that because based on my familiarity with Pine Creek and Paradise Valley. 2022, this is the last year of my study. After 10 years of regrowth, the NBR mean has shifted to 0.116 from near 0 in 2013, so it has improved. And 12% of the study area has an NBR value of 0 or below, compared with 51% of it in 2013. So that also indicates that there has been some regrowth and some improvement in the area. The NDVI side, the mean has recovered to 0.21, which is comparable to what we saw in 2011. Parts of the northeast and southeast here still classify as unhealthy level 3, which is the least healthy classification. It's hard to know what this means in an alpine forest context, since these areas were inaccessible for ground truthing. These next 2 slides show animations of a sort. The first one illustrates the temporal changes in burn severity from 2011 to 2022. And the second shows changes in NDVI classifications for the same time period. So here you see the area is largely unburned in 2011. In 2013, there are some significant changes brought by the fire. Here you can see clusters of the red pixels that indicate the moderate high burns. This is the highest burn severity that I saw in the entire study. So you've got those there, you've got a couple here, and then you've got 1 up here. Then moving forward, you're going to see the green unburned areas slowly start to move back into the area. By 2016, these moderate low burn severity pixels had largely disappeared from the map. So moving into 2019 and 2020 and 21 and 22. And just for comparison purposes, I'm going to move us back to 2011 just for comparison. And you can see that from a reflectance standpoint, 2011 and 2022 are somewhat comparable. NDVI. Again, bear in mind that the darker orange colors indicate healthier vegetation. This is unburned in 2011. 2012, this is still a pre-fire year. This is one of my Landsat 7 data sets. And here you can see the lost data, the zigzag patterns. What happened on Landsat 7 was it suffered a scanline corrector failure, which compensated for the wiggle motion in the satellite. When that went bad, all the subsequent data sets had this wiggle in it and they were unable to correct it. So it's the data that's still there is still good to use, but when you're trying to mix it with other data sets, you really need to stick probably with Landsat 8 or Landsat 9, which is what I did. So this is 2012 pre-fire. 2013, Unhealthy level 3 dominates much of the east side of the study area here. And then moving on from 2014 to 2022. These changes are similar to those that we saw in the NBR animation. Grasses and shrubs are the first plants generally to return after a wildfire. And I suspect that much of this regrowth that we're seeing here is due to that, but not having ground truth much of the area, it's kind of hard to say. Interestingly, this is what the area looks like from a reflectance standpoint in 2022. I'm going to take you back to 2011. It's kind of hard to tell the difference, but reflectance-wise, their NDVI values are very similar between 2011 and 2022. Back in June, I had an unexpected chance to conduct a limited ground truthing expedition in the area. Accessibility was the central factor in choosing these sites. The Absarokas offer challenging backcountry travel, and I did not have adequate gear for a couple of overnights in the backcountry. Also, late spring weather in Paradise Valley is highly unpredictable. There was a gorgeous 60-degree Sunday in May, and overnight they got 2 feet of snow. So that's spring in Southwest Montana for you. But these 3 sites I visited in person: PC Test 1, PC Test 2, and PC Test 3. PC Test 4 is included here not because it was a good site for ground truthing, but because it illustrates the importance of in-person ground truthing when using NBR and NDVI indices. So going on to PC Test 1, this is in Pine Creek. This is where the fire first ignited. DNBR classifies the area as unburned. NDVI classifies it largely as mid-level unhealthy level 2. The only living vegetation seen in Pine Creek Test Site 1 was grass and shrubs, which you can see here in both of these photographs. There was no clear evidence of new saplings in spite of the abundance of trees that once grew here, which you can see here in the distance. These results were somewhat inconsistent with my expectations, although after I did Pine Creek Test 2 and 3, I've since changed my mind about the validity of this. I think these results, these reflectance results, are actually fairly accurate, but I'll have to explain that here after I get through PC Test 2 and 3. Pine Creek Test 2 is located 100 yards east of the Pine Creek Trailhead. It's an easy hiking trail in the area. DNBR classifies the area as unburned with 1 low severity pixel still in evidence. Interestingly, the NDVI classifications classifies the area as moderately healthy level 3, which is some of the best readings that I saw. This green here. Grasses and shrubs are evident in the photographs. Importantly, the Douglas firs and lodgepole pine seedlings are growing extensively at the site. I suspect that the added biomass from the trees has improved the NDVI readings. I did not see readings like this at Pine Creek Test Site 1. This is much more in line with what I expected from my NBR and NDVI readings, and it's why I now go back and say that the readings at Pine Creek Test Site 1 may have been accurate for what I was seeing in person at these sites. PC Test 3, let's see, PC Test 3. This setting is similar to that of PC Test 2. The elevation is comparable to what we saw just a second ago. It's located in a shallow valley, provides some protection from the elements, and there's a constant source of water. DNBR classifies the area as unburned with 1 or 2 low severity pixels still in evidence, and NDVI classifies it as unhealthy level 1 to moderately healthy level 3. So again, just like PC Test 2. There's thick ground cover here, ample evidence of grasses and shrubs, and solid regrowth of trees. Douglas firs are here. The pines in particular, some of them are over 10 feet tall. So they have grown back very well in this little section here. This is called Deep Creek. I can't call Pine Creek Test Site 4 a ground truth site since I couldn't reach it either on foot or with my drone. I include it here because it demonstrates the importance of in-person validation of reflectance results. This mountainside is a prominent feature in the north part of Paradise Valley. You can see it from a distance. You can tell there was a fire, but you can't see any obvious signs of regrowth from 2.5 kilometers away. NBR classification, largely unburned. NDVI is a mix of unhealthy level 2, unhealthy level 1. Regrowth is taking place, and while we can speculate that grasses and shrubs are responsible, we don't really know what's going on, and we don't know if any trees have returned. So if I'm going to make statements about burn severity or post-fire regrowth, I have to put boots on and go out there and see these sites and confirm what my readings say with what I'm seeing on the ground. In conclusion, overall, the burn severity for Pine Creek was moderate low with a few isolated instances of moderate high. And this agrees with in-person assessments that were made by Forest Service personnel, several of whom I was fortunate to visit with this past spring. They've been monitoring the area personally since the fire burn. It's recovering quite well for a moderate low severity burn. There are no dangerous erosion conditions anywhere in the backcountry, and they see no need for remedial action, and none is being planned. NDVI is not a good indicator of burn severity, but it wasn't designed to be used that way. It can definitely be used as a signal when changes are taking place, but in-person investigation is required in order to see what those changes are. Regrowth and recovery. There's some correlation between observed regrowth and NBR values, but NBR should not be used as the only measure. NDVI has potential to be used much more extensively in post-wildfire assessments, but you have to have that baseline of NDVI values of healthy versus unhealthy vegetation, or you're going to be making assumptions that can be very, very wrong. I found that out myself. So, and the scale that you use needs to be customized for the vegetation type that you're studying and the characteristics of the area and the time of year. So in conclusion, NBR and NDVI indices are useful tools for making post-wildfire assessments when they are used in tandem. They can definitely alert forest managers to problems and direct them to places that need human assistance to recover, but they should not be relied upon as independent measures of burn severity or post-wildfire recovery without a clear and concise ground truthing strategy for validation. And that concludes my presentation. Thank you very much.